Good morning. This is Unit 3, Day 8 notes, and we're going to go over how to find the closest approach. So this says a ship sails through point A in direction of B past port P. So I'm going to put P as maybe like right here, port. And my ship is sailing, doesn't matter, this way maybe, and this is my direction from point A. And we want to know when this is the closest to the port. Well, we know that this is going to be the closest. I actually showed you guys how to do this using the distance formula, and R, which R is going to be closest. So I actually showed you guys using the distance formula, but we can also do this using the dot product, because the closest point, or the closest that our ship is going to be to the port, is always going to form a perpendicular line. So this is my ship, this is my initial position, this is my ship's direction, this is B. And my ship is going to be closest to the port when this AB is perpendicular to P. Well, this is going to be R right here, my closest point, PR. So this is going to form a 90-degree angle right here. And that is going to be the shortest distance. So when PR is perpendicular to B. All right, we are going to try this. It says the annual water balloon fight, Miles has somehow managed to gain control of a jet ski. Miles starts inland at A is -8.3 and is moving in the direction of 3.4 at a speed of 10 kilometers per hour. King, who is on the opposing team, is landlocked without transport at 10-2. Okay, so what I would do is I'm just going to draw a land. It says land is over here. And it looks like we are going to have a jet skis, and it starts at A, which is -8.3. And it goes in this direction of 3.4. So I'm going to make it kind of go to the right and up, 3.4. This is my direction. Okay. And it says that Kang is over here at 10-2. And we want to know when Kang is on the opposing team landlocked, is trying to plot when would be the best time to throw the water balloon. She wants to figure out when the jet ski will be closest to her, and she will have the best control to aim at the water balloon. So remember, this is going to be the closest when this line is perpendicular to the jet ski. That's going to be the closest. First, we need to find the position of the jet ski in terms of T. So my position is XY. It says that our jet ski starts at -8.3. And T times my directional vector. But my directional vector, it might not be 3.4 because it says my speed is 10 kilometers per hour. So remember, we have to take the magnitude of my directional vector. We did this on our last warm-up. Equals, it says the square root of 3 squared plus 4 squared, which is 9 plus 16, which is the square root of 25, which is actually 5. And we want it to be 10. So I need to multiply it by something to get 10. So I'm going to divide by 5. I'm going to get K has to equal 2. So then I multiply 3.4 by 2, which then I get 2 times the 3.4 is 6.8. And that is going to be my velocity vector, 6.8. And this is my velocity vector. Okay. It says by the time Miles' jet ski is closest to King 10-2, when should he attack? When should she attack? So what time is going to make this closest, or this perpendicular line? Well, this occurs when K2, let's make this point right here R. KR is perpendicular to this vector B, or this, the jet ski B. Okay. Well, let's find KR. I don't know where KR is. I need that vector first. Just remember KR is R minus K. All right, well, I know what R is, this point. So I'm going to use -8 plus 6t and 3 plus 8t. And then I know what K is. So -8 plus 6t and 3 plus 8t. And then I'm going to subtract K, which is 10-2. I can combine like terms. That'll help. I think I get 6t and minus 18 and plus 1. Okay. And this is my vector KR. Alrighty. Now we know that we want these vectors to be perpendicular. So they are perpendicular, remember, when the dot product equals 0. KR is perpendicular to B when the dot product of KR dot B equals 0. We need this to equal 0. We found KR. This is 6t minus 18 and 8t plus 1 dot B, which is 3, 4. When this equals 0. Okay. And I really just care about the direction, because remember when we talk about slope, the slope of the line is what makes it perpendicular. The direction of this of the jet ski is going to be what makes it perpendicular. So remember, to do the dot product, you multiply the x's. So this is going to be 3 times the 6t minus 18 minus, and then 18. That's not a plus. And then plus, we multiply the y's. So 4 times 8t plus 1 equals 0. We have to set it equal to 0. We want to know when it equals 0. And then I'm going to distribute this 3. 3 times 6 is 18t minus 3 times 18 is 54. 4 times 8 is 32 t plus 4 times 1 is 4. And I'm just going to combine my t's. Luckily, this is not quadratic. It looks like it is 50t. Check it, guys. Minus 50. Add that 50 to move it to the other side. I have 50t equals 50. And divide by 50, I get t equals 1 hour. After 1 hour, that would be the best time. Awesome. Is that the last part of this? All right. So the first part is super easy. It says this is a particle moving such that x and y, this is parametric, and t in seconds, distant units are in centimeters. Find the initial position of P. We remember this is my initial position, 2, 1. You can write it as a vector or just 2, 1. How close to, let's say this is Q. 0, 10, did the particle pass, and what time did this occur? These are two very different questions. So let's draw a line or a vector. And so this is our vector. And we need our slope, which looks like it's going to be -1 and then 3. So my vector, or b, is -1, the numbers in front of the t, and we want to know q, let's say, is down here, and it says it's 0, 10. How close to the particle pass, so the minimum distance is going to be when this is perpendicular. Pretend like that's perpendicular. That was horrible. Okay. And it tells you that your position is 2 minus t, comma, 1 plus 3t. Alrighty. So how close let R be any general solution on the line? So let's let R be any general solution on the line closest when Q to R, so this is going to be our spot, when Q to R is perpendicular to B. So we're going to let R be at that closest point on the line. In order for this to be perpendicular, we need to find Q to R. We're going to do just kind of like what we did in the last question. Q to R is R minus Q. And R, we can use our position. So 2 minus t and 1 plus 3t. And then subtract Q, which is 0, 10. This gives us 2 minus t. And we're going to combine these like terms, 3t minus 9. I would like the t's to be second, but we can fix that. Okay. Now we need to know the closest point is when the dot product equals 0. So the dot product of Q to R, that vector, and the slope of this, which is B, has to equal 0. So Q to R is 2 minus t, just did this, 3t minus 9, and B is -1, 3. We're going to find out when this equals 0. I think this is -1, parentheses, use your parentheses, 2 minus t, plus, and then 3 parentheses, 3t minus 9. And this gives you -2 plus t, plus 9t minus 27 equals 0. Find out where this equals 0. And this equals 0. This is going to be 10t minus 29. Move the 29 over, divide by 10 when t equals 2.9. I believe we're in seconds. Distance, or t is in seconds, sorry. T is in seconds. So 2.9 seconds. Okay. Now that is actually a different question than how close did it pass? So this is the closest at 2.9 seconds. So what time did it occur? We answered what time did it occur. But how close was it? Well, we've got to plug it in and find out the magnitude of QR. Find out how close this vector is. All right, so we want to know the magnitude of QR when at 2.9 seconds. I'll try to do it over here. So the magnitude of QR at 2.9 seconds. So this is QR, is the magnitude of 2 minus T is 2.9. And 3 times 2.9 minus 9. The magnitude of this. Simplify it first. 2 minus 2.9 is negative 0.9. And 3 times 2.9 minus 9 is maybe like 0.3. Try it. Oops. Oh no. Sorry guys. Okay. Negative 0.9 and negative 0.3. The magnitude of this, which is equal to the square root of negative 0.9 squared plus negative 0.3 squared. Remember, when we square it, it becomes positive. You're not going to get a negative in there. I got something like 0.948 centimeters. Just check. I think we're in centimeters. Check and make sure I'm right. All right, guys, what I want you guys to do is try this one. I'm going to help you set it up a little bit, but I want you to try it. It says a yacht, I want you to draw a picture, is sailing with a constant speed of 5 square root of 10 kilometers per hour in the direction of, this is my direction, initially its point is negative 610. A beacon is at 0, 0 at the center of a tiny atoll. Distance r in kilometers. Find in terms of I and j the initial position vector of the yacht. So they gave us our initial position right here is negative 610. They just want it in terms of I and j. Negative 6i plus 10j. The velocity vector of the yacht is all right, so this is the direction is -1, -3, right here, -1, -3. So I'm going to find the magnitude of -1, well, -3. And this is the square root of -1 squared plus -3 squared. But we need this to equal, times k has to equal 5 square root of 10. This is my speed, 5 square root of 10. So when I divide by the square root of 10, I get k equals 5. So my velocity vector is, I'm just going to write it in terms of I and j. 5 times negative I is negative 5i. And then -3 times 5 is negative 15j. This is it. I just wanted to show you what it looks like with i's and j's instead of in the vector form. In position vector of the yacht at time t hours, we have everything we need. So remember, we write x, y equals my initial plus t times my velocity, -5, -15. Find the time when the yacht is closest to the beach. So you're going to have to find the vector for it, which is going to be something like this, minus, actually it's going to be -0, 0 probably, right? And then you are going to use the dot product and find out when that equals 0. I want you guys to try this one. Make sure you guys get it right and ask me if you got it right, okay? And try this one. If you have any questions, please let me know.